Hello. Today we're going to talk about Topic 5, Section 9, Further Differentiation. This section starts out with a review of the power rule, but hopefully we all remember it. We just took a test on it, and now we're going to start taking derivatives of all the other functions. So the first one we'll start out with is the exponential function. Now, on the left-hand side, this is what they give you on the formula booklet. This is what they don't give you, okay? So you need to remember this, okay? So, I know I just erased it, but, write it down. It's important, okay? Now, let's do an example. So the first one, we first want to make it as e to the power. So rewrite this as 2/5 times e to the 3x minus 4. And so now when we take the derivative, all we have to do is take that, whatever's multiplying by x, bring it out front. So this would change to 2/5 times 3 times e to the 3x minus 4. You simplify it, you make it look nicer. There we go. Okay? So it'd be 6/5 e to the 3x minus 4. Alright, next one. Do the same thing. Rewrite it. 7/6 times e to the negative 2x. All we need to do is take 7/6 times negative 2 times e to the negative 2x. You simplify that, and let's see. You should get this, right? Typically you want to write it with a positive exponent, so that's why you'll see it move down. So this simplifies to negative 7/3. Since that's a negative exponent, bring it down to the bottom. Okay? So there's your answer. Alright, now the natural log function. This one is in your formula booklet. This is not. So you have to remember this. Okay? It's whatever's in the argument, so natural log of whatever, that goes in the denominator, but you also, whatever you're multiplying by x, multiply it by the whole thing. Okay. Starting out, you want to make sure that it's just natural log. You don't want this exponent. So remember your rules. Take that and multiply it. So we get 10 times the natural log of 3x minus 4. So we know that the argument automatically goes down in the denominator, and then you take whatever was in front, you multiply it by whatever's multiplying by x. So we should get 30 over 3x minus 4. And notice that's what I got. Example number 2, same thing. Make it so it's natural log. Rewrite this. 1/3 natural log 7 minus 12x to the 1/2. Rewrite it again. 1/3 times 1/2. Exponent goes out front, times the natural log of 7 minus 12x. So when you rewrite this, okay, you're going to take 1/3 times 1/2, whatever's out front, times whatever's multiplying by x, so times negative 12, all over whatever the argument is, 7 minus 12x. So 1/6 of negative 12 is negative 2 over 7 minus 12x. So we double check it, and notice that's the same answer I got. Okay, it's the same because what if I multiplied it by negative 1? okay, then it would be the same as this. It doesn't matter. I don't care. You can write this as the answer, right? Or you can rewrite it so you have less negatives, okay? Either way is acceptable. All right, derivatives of trig functions. Haha, guess what? This is on your formula sheet. This is not. So you need to remember. Luckily, there's a theme. If there's something on the inside that you're multiplying by x, you just multiply it by whatever's out front. Okay, so just remember that idea. So here, we want to do the derivative of sine. Derivative of sine is cosine, so now we know it's cosine of 6x plus 4. But now we take whatever's outside, multiplying by x, and multiply it by whatever's outside. So 5 times 6. So the answer should be 30 cosine 6x plus 4. All right, we double check it. All right, and we get the same thing. Oh, there were more examples with trig functions, but we do not have to go and do the crazy like sine squared or cosine 2x or any of those things. They show you just because it's cool, but we don't have to take it that far. So we're not. Now, this is the chain rule. So if you have a function within a function, okay? So what do I mean by that? Okay, well, look at example 2. I know we've done this one, but maybe you didn't realize that the exponent could be multiplied out front, okay? Start second guessing yourself. So what we could do is we have the big function, which is like g of u, we'll call it that, is 2 times the natural log of u. Okay, that's the main one, 2 times the natural log. Then what's inside that u, okay, that u of x is what this is, this 3x minus 4 to the 5th. Okay, so let's start by taking the derivative of both. So the derivative of just g is just 2 over u. Okay, and we know u is just that function we plugged in. So 2 over 3x minus 4 to the 5th. Then u of x is, let's do the derivative of that. Okay, that's just 5 times 3x minus 4 to the 4th. And then we multiply it by that k value because we're multiplying, right? So that just gets us 15 times 3x minus 4 to the 4th. Okay, so now watch what we do. We do the derivative of g times the derivative of f. Okay, well, we called it u of x. So 2 over 3x minus 4 to the 5th times 15 3x minus 4 to the 4th. Luckily, a lot of those are going to cancel, and we get the same thing we started with. Okay? Or not what we started with, the same thing we got on the last way we did it. Okay? It's just showing you a function within a function. I know, it's weird. Let me do it again. I know. Okay. So example 4. So we have our original function is g of x. Okay, and then we plug in the function x squared minus 15. So we're going to let u of x be x squared minus 15, and our g of x is just plugging that in. Okay, it's f of u. Okay. So now we take the derivatives. So we want the derivative of the big function. So just the derivative of f, oh, well, when it's 5, right? We're plugging in 5. Oh, I erased too much. So we want the derivative of 5. So that's the derivative of when you're plugging that in. So it's got to be of u. 5 squared minus 15, right? U is just x squared minus 15. So that is just the derivative of f at 10, which we know is 7. So the derivative of g is just 7, okay, at 5. Now do the derivative at u at 5. I'm sorry, the derivative of u at 5. So the derivative of u is just 2x. So 2 times 5 is just 10. The derivative of g times the derivative of u is going to give me my answer. So you're doing the derivative of the big function, ignoring the little function, just leave it the way it is, times the derivative of the little function. So let's see, we should get 70. Yes, perfect. So we got it. All right, so here's a chart to hopefully make this function within a function easier for you. Again, I would practice this, okay? So start with your big function. Big function is something to the 5th power, okay? The function within a function is the x squared minus 2x. That's your u. That's what you're plugged in. So the derivative of g is just 5 times u to the 4th, right? It's power rule. The derivative of f is just 2x minus 2. And the derivative of h is a function within a function. So the derivative of g, so 5u is x squared minus 2x to the 4th power times the derivative of f of x, which is 2x minus 2. And that's how you fill it out. Okay, practice this. I'm going to just explain them all. So this one, we can think of it as 1 over u, or u to the negative 1. And our f of x, we can think of x cubed minus 4x squared. Then the derivative of this one would just be negative u to the negative 2. Well, here, actually, I'll do both. I'll do, if you did the left side, it would be negative 1 over u squared, or you had negative u to the negative 2. The derivative of f would just be 3x squared minus 8x. And so now you can just rewrite it. I'm going to use this one, so I just like the fraction. So we're going to have negative u squared, so that's just x cubed minus 4x squared squared. And then on top would be 3x squared minus 8x. Okay, I'm going to fill in the rest and see how you got it. All right, so this is the rest of the chart filled out. Hopefully this makes sense to you. think of it as one big function and you're plugging in a smaller function. I know it sounds weird. That doesn't make sense. I can walk you through these one at a time, one-on-one. But yeah. Oh, and just so you know, this right here, that's a 3. It was just hard to fit it all in that little tiny box. Okay? So feel free to ask me in class, and I can talk to you one-on-one. Okay, so product rule. The idea here is if you've got two functions multiplying together, okay? So think of them as two separate things. So we have u of x can be this x cubed plus 7, while the other one can be e to the negative x. Okay, you do the derivative of each one. So this would just be 3x squared, and then this one should just be negative e to the negative x. And then you mix and match them. You multiply these, you multiply those, and you add them together. So you get negative e to the negative x times x cubed plus 7. Add it with these two multiplied together. So 3x squared e to the negative x. Okay? That's the product rule. All right, let's do another one. So you have, let's see, you have the left side is this x squared plus 1 cubed. The right side is the natural log of 2x. Okay, the derivative of this is, that's the chain rule. Okay, so 3 times x squared plus 1 squared. And then the derivative of the inside is just 2x. Right, the derivative of natural log is just 2 over 2x. So just 1 over x. All right, now we match them up. So we have x squared plus 1 cubed over x, and then we're adding that with the inside ones. Ooh, lots of things to multiply. So let's see, let's make that 6x, then x squared plus 1 squared. I just did 3 times 2x. Okay, and then times your natural log of 2x. Okay? Okay, we do it again. We have the left side. We have the right side. The derivative of this is a chain rule, so a function within a function. So the derivative of the big function is just ex squared. Inside function is just going to be 2x. Derivative cosine is negative sine. And then we mix and match. So we get negative ex squared sine of x plus these two multiplied together. So I'm going to rewrite it kind of nicer. X squared cosine x. All right, and for the last one, we have sine of 5 minus 2x. Then we have the natural log of x, left side, right side. The derivative of this is a function within a function. So the derivative of sine is cosine times the derivative of the inside, which is just negative 2. Derivative of natural log of x is just 1 over x. Mix and match them. Sine of 5 minus 2x over x plus, and this one's kind of gross. We're going to just try to write this nice. Natural log of x cosine of 5 minus 2x. Okay, sorry, I know it's boring, but that's the idea. Identify your left and your right side, take the derivative of each, mix and match them, right? Notice it's u and v prime, v and u prime. Okay, and then you just add them together. Oh, I meant to do the examples first and then do the chart, but that's fine. All right, so now think about these. Okay, why don't you guys give these a whirl? All right, again, identify the left and the right side. So you have sine of sine x cubed, and then you have cosine x. The derivative of sine cubed, that's just a function within a function. So that's 3 sine squared x times the derivative of sine, which is cosine. The derivative of cosine is negative sine. So now we get negative sine to the 4th plus, let's see, we could multiply this out if we wanted to, 3 cosine x sine squared x minus cosine squared x. Okay. What did I do? Oh, I'm so silly. This is why it helps to have better handwriting. That is a multiplication sign. Silly, silly me. Okay, have better handwriting. That's what you need to learn there. This was times cosine x, right? The derivative of sine is cosine. Okay, so this all multiplied together is 3 sine squared x cosine squared x. Silly me. Okay, I'm going to try that again. Okay, left side, right side. Okay, what's nice about this is here I'll show you a little shortcut with this, is you could treat this as like those two times that, or you could have done this times those two. Perfectly fine. But then you would have noticed you would have had a product rule within a product rule. Okay, so what I do is you have your 3 main functions. You have your square root of x, you have your e to the x, and you have your sine x. Okay, then they're all going to be multiplied by a third thing, or by 3 things. So you have the square root of x and sine of x. They're going to be multiplied by, well, here, hold on. I'm trying to figure out the best way to explain this. Sorry. Oops, sorry. Okay, so let's see. Try this again. I don't like how I explain that. Sorry. Back scratch. Or backs. Ooh, it's a little late, a little tired. So the first thing you're going to do is you're going to leave the first 2 alone times the derivative of the third. The derivative of the third is just cosine. Then you're going to add the first one, the last one, and then do the derivative of the middle one. The derivative of e to the x is just e to the x. Okay, then you're going to leave the second and third one alone and take the derivative of the last one. I guess I should have done dots. Okay, so the square root of x. The derivative of square root of x is just 1/2 x to the negative 1/2. Okay, so I know it's super gross, but this is what it is. Okay, And if we check it, all right, we end up with the same thing. Ooh. What are they doing? Why do they gotta write it all weird? Okay. Oh, they made it all with the same denominator. Yeah, because this one's gonna be e to the x sine x, and then 2 square root of x. Yeah. So they made everything else have the same 2 times the square root of x. Okay, so they all got the same denominator. So multiplied everything, top and the bottom, by 2 times the square root of x. Okay, it's the same thing. Either way, I'll be able to recognize both of those. Okay. Yeah, the book was really big on simplifying. All right, the last one on here, let's see. This one, okay, so they just give you what f and f prime is. You know g of x is this, so find the derivative. Well, it's a product rule. So you do x squared minus 15 times the derivative. Then you add the derivative of x squared minus 15, so that's just 2x, times f of x. And now just plug in your 5. So we're going to get 25 minus 15, f prime of 5, then what, 2 times 5, and then f of 5, there we go. So then we get 10 times f prime is 2 plus 10 times negative 3, 20 minus 30, we should get negative 10. Hopefully I'm right. There we go. Perfect. Okay. Hopefully this is making sense. That's the product rule. Okay, so this is the quotient rule. What I learned is kind of like a little jingle. It kind of reminds me of Snow White and the Seven Dwarfs. So you have the derivative or the function on top divided by the function on the bottom. So high over low, right? That makes sense that high is above low. Okay. All right. Okay. How you want to remember this is low, then the derivative of high minus high derivative of low all over low times low. So you say it, low d high minus high d low all over low low. Okay. Low d high minus high d low all over low low. All right, you start with low. You end on low. Okay? All right, they give you the rule, but it looks like this. Okay? So v, the derivative of u, the function u of x. Yeah, it's a pain. Oh, I have the answers showing on this one. Oh, silly me. Okay. Well, now we know how to get there. So express the derivative, okay, of g of 1 over f in terms of f and f prime. Okay. So we have high and low. So low d high, the derivative of high is just 1, minus high, which is 1, times low d, or d low, high d low, sorry. So the derivative of the denominator, so f prime, all over low low. So this is f minus f prime all over f squared. I can't believe I just did that. I just said the derivative of 1 was 1. What? I hope you caught me. I hope you realize that was silly of me. F times 0. So this goes away. Okay, so then there we go. There's our answer. Ugh, silly me. Okay, now the next one. All right, I know I kind of gave the answer away, but we can still figure it out. So let g of x be this, and h of x is f over this. All right, we want to find the derivative of g at 5 and h at 5. So let's start. Oh, I don't even have both of the answers. So let's just start with this one. Okay, let's start with this one. So the derivative of g, so we have low d high, so derivative of the high one, so 2x, minus high d low, all over low, low. So now we plug in where x is 5. I guess I should just put equals 5. So now we plug that in. And so when f is 5, it's negative 3 times 2 times 5, which is 10, minus 25 minus 15 is 10. F prime of 5 is 2, all over negative 3, negative 3. So 30 minus 20, all over 9. So negative 50 over 9. Then for h prime, all right, so now we're just doing the flip of it. So low d high minus high d low, so the derivative of the low one is 2x, all over low, low. Let's see if we get something else. So now we plug in x equals 5, and we get 10 times 2 minus negative 3 times 10, all over 10 times 10. So 20 plus 30 is 50 over 100, which is 1/2. Okay, so see how it matters which one you label as low and which one you label as high? Okay, that's what you wanted to see here. Notice we got 2 different answers. All right, so here's some practice on your own. So try to do these on your own. You have low d high minus high d low all over low, low. Okay, so take a minute, pause it, and then I'll just show you these. All right, sorry. I guess I didn't leave myself quite enough room to rewrite this. So I smushed them in here. Like that's all on one numerator, just so you know. Anyway, if you'd like me to walk you through them, all right, if you don't understand how I separated them and then the derivatives I've got, please don't hesitate to ask me. I will gladly walk you through this in class. All right, now for the word problems. Okay, so this is how you want to remember to solve a word problem. First, you've got to understand what you're trying to do, develop the model, write your equation, differentiate, substitute, blah, blah, blah. It makes more sense once you do it. Okay? Okay, so starting with example 1, we understand that the height of the entire cone is 10. We know that the radius is 5. That's of the original, the actual full size. And it's being filled at a rate of 1.5 cubic centimeters per second. what's the height of the, when the height of the water is 5 centimeters, what is the rate at which the water level is changing? Well, first, name down some things you know. You know that the volume is 1/3 base times height, so pi r squared h. You also know that the ratio from the radius to the height is 5 to 10. Okay, so if I wanted to replace this, okay, if I wanted to like substitute the r, for instance, I can rewrite this as r equals h over 2, right, multiplied by h. Okay, so then I could rewrite this and say the volume is 1/3 pi r, oh well, I'm replacing r with h over 2 squared times the height. So the volume is going to be what, 1/12 times pi times h cubed. Now, once we've got that taken care of, we know that it's filling at a rate of 1.5 cubic centimeters per second. That's the volume. So differentiate. So take the derivative of both sides. It's supposed to be a tick mark. And then the derivative of this is going to be what? 1/4 pi h squared. Right? Where the derivative to h to time. This is the derivative of volume, but we know that's being affected by 1.5. So now, oh, I was wondering, I was like, I can't solve that. I'm thinking, what am I missing here? We also have, when the height of the water is 5 centimeters, what is the rate at which the water level is rising? So now this h right there is supposed to be a 5. So now you're getting that derivative by itself, or this dh over dt, because you want to know what's the rate at which the water level is rising. Okay, we want the height, or over time. So let's see, multiply by 4. What is that? 6. So we should get 6 over 25, because 5 squared. 25 pi is going to be our rate of change. Yeah, 6 over 25 pi. Perfect. All right, I know. I'm going to walk you through it again. So read through question or example number 2. So we have this figure. Okay, what do we want to do? Okay, I magically just changed that second question because I did not like that example. You're not going to have anything that crazy with trig, so we're going to stick to something more basic. So let's do this one. It was one of the section questions from topic 9, one of that last sections, reading sections. Okay, so for this one, all right, police car is traveling that direction, heading east, and a car is traveling north, okay, and their car, or distance between them, is increasing. Okay, so, oh wait, I didn't transfer the question. There we go. There's the question. How fast is the second car moving? Do not give units with their answers. Round to the nearest hundredth if necessary. Okay, so we know that we've got a triangle here. So what we can do is we can use the Pythagorean theorem. We have x squared plus y squared equals our hypotenuse. So we'll just call it k. It doesn't really matter. Okay, so we take the derivative of both. We get 2x plus 2y equals 2k, or you can think of that as x plus y equals k. Now when we do that, you want to think of it as, since you took the derivative, okay, so really you want to think of this as x times the derivative with relationship to x, okay, plus y times the derivative, that's the derivative of y over the derivative, or the change in y over the change in time. Okay, oh, not y, what am I doing? Okay, so if we think of this as a regular triangle with our distance being the way it is, 1.2 squared plus 1.6 squared equals k squared, we solve this, we should get k equals 2. Okay, now it told you the speeds of the police car and the other car, or the distance between them, is increasing. So what I mean by that is that this 25 and this 90 are going to replace the change, the rate. And what we're looking for, how fast is the second car moving, we're looking for that rate of change. So when we plug all those in, okay, we know x is 1.2. That police officers traveling at 90 miles per hour, plus y is 1.6, then that's the change in y over the change in time, equals 2 times 25. Okay, one slight thing we need to notice here is that this 90 is going to be negative, because it's approaching the stop while the other car is going in the opposite direction. Okay, so one car is approaching, one car is moving away. So since we're approaching it, we're coming from that left-hand side, we're making that negative. Okay, so now when you solve that, you should get this. Okay, so when you solve for, here, let me do that in pink. When you solve for dy over dt, you should get, well, approximately 98.75. Okay? I know word problems are weird. Just go ahead and ask me. Okay? I know they're weird. Just ask. All right, and this is everything we learned in 5.9. Let me know if you have any questions.